Alright, we still have other examples, as what you can see on the screen. Now, love us to take, now if you look at number 6, number 7, number 5, okay, let's take number 5. We have 1 over 27 raised to the power negative 1 over 3 times 16 raised to the power of 1 over 4 times 8 raised to the power minus 2 over 3. We are to evaluate that. 1 over 27 raised to the power negative 1 over 3 times 16 raised to the power 1 over 4 times 8 raised to the power minus 2 over 3. Now let's solve that and see how we can successfully use the laws of indices to be able to evaluate that. Alright, so we have 1 over 27 raised to the power negative 1 over 3. Okay, let's check the equation again. 1 over 27 raised to the power negative 1 over 3. Okay, that's correct. Okay, we have times 16 raised to the power 1 over 4 times 8 raised to the power negative 2 over 3. Now this is what we are to evaluate. Alright, you can observe here with me that negative 1 over 3 is the power for 1 over 27. So that power affects only that first number, 1 over 27. And we have said earlier that I have noted earlier rather that anytime a number is raised to a negative power, the negative sign is used to take the inverse of that number. Alright, so this negative 1 over 3 now becomes 1 over the number earlier was 1 over 27, okay, raised to the power of 1 over 3 now, times 16 will still remain 16 raised to the power 1 over 4 times, we do the same thing to this number 8 is raised to negative 2 over 3. That negative sign takes the inverse, that's 1 over. So we have 8 raised to the power minus 2 over 3 becoming 1 over 8 raised to the power 2 over 3. That negative sign is the inverse that we have taken at that point. Alright, so this is equals to, now for this guy, 1 over 27. Anytime you take the inverse of a fraction, you invert the fraction. That's, you take, you turn it the other way around. Numerator becomes the denominator and denominator becomes the numerator. So if we take the inverse of 1 over 27, so that now becomes 27 over 1. And anything divided by 1 is still that same thing. Anything multiplied by 1 is still that same thing. Anything raised to the power 1 is still that same thing. You see, 1 is an innocent guy. Whenever you use 1 to multiply by any number, that number still remains itself. Use 1 to divide any number, that number still remains itself. Raise a number to power 1, that number still remains itself. 1 is an innocent guy that doesn't harm anybody, is just around, making life easier and simple. Alright, so we have 1 over 27 means 27 divided by 1, which is still 27. The innocent guy now, that's 27 divided by 1, 1 is innocent. Alright, so we have 27 raised to the power 1 over 3 left here times 16 raised to the power 1 over 4 times, now here we cannot actually say 8 divided by 1 because we did not have 1 divided by 1 over 8. The fraction was not 1 over 8 to start with, so that when we now take the inverse of that, like we had in 1 over 27, it becomes 8 over 1. This one is just 1 over 8 raised to the power 2 over 3, so it will still remain that way. We are not taking the inverse by reverting it now. Alright, so this will still maintain itself as 1 whole number divided by 1 divided by 8 raised to the power this. Okay, alright, so over here we are having 27 raised to the power 1 over 3. Now we have discussed this already in the laws of indices. This is actually the last law of indices. When a number is raised to a fractional power, denominator of that fraction picks the root sign and the numerator still remains the power of the number. So 27 raised to the power 1 over 3 means denominator of that, which is 3, takes the root sign, and of course the root sign for 3 is cube roots. So we have cube roots of 27. Cube root of 27 raised to the power 1. 1 is that innocent guy, it is harmless. Okay, times 16 raised to the power 1 over 4. So here denominator is 4, so it will take the root sign, which is 4th root. So we have 4th root of 16 raised to the power 1 times 1 over denominator of 8 here, that's 8 raised to the power 2 over 3. Denominator of that fraction is 3, so we have cube roots. We have cube roots of 8 all squared. Alright, so this is equals to, now cube root of 27 is a number that when we multiply 3 times we still have 27. Cube root of 27, you multiply 3 times, you have 27. So cube root of 27 will give us 3. 3 raised to the power 1, the power there was 1, times the other one was 4 root of 16 all raised to the power 1. Now 4 root of 16 means the number that when you multiply 4 times you have 16. 2 times 2 is 4. 4 times 2 is 8. 8 times another 2 will give us 16. So 4 root of 16 means 2 because when we multiply 2 4 times we have 16. Okay? So 4 root of 16 here is 2 raised to the power 1 times 1 over, we had cube root of 8 all squared. Now cube root of 8 is a number that when you multiply 3 times you have 8 and that number is still 2. Take note, multiplying 2 4 times will give us 16. So that makes 4 root of 16 to be 2 because 2 is actually multiplied 4 times to have 16. And multiplying 2 3 times will give us 8. So cube root of 8 is also 2 because when we multiply 2 3 times now, we are going to have 8, not 16. 16 is for 4 roots. 4 root of 16 is 2 because 2 in 4 places will give us 16. Alright, so cube root of 8 is 2 because if we multiply 2 3 times, we have 8. So here we have 2 raised to the power what? 3. Okay, so this is equals to, now 3 raised to the power 1 is still 3 times 2 raised to the power 1 is still 2 times 1 over 2 cube is 2 times 2 times 2, which is 8. So we have 8 under. So this equals to, we multiply the numerators together, 3 times 2 times 1, that will give us 6, all divided by 8. Now both 6 and 8 are numbers that 2 can divide combinately. They are even numbers. Alright, so we can say 2 into 6 is 3 and 2 into 8 is 4. So our final answer becomes 3 over 4 as the evaluation of that particular mathematical exercise using the laws of indices. Now we have 2 more questions left. So number 6, we have to evaluate 3 whole number 3 over 8 is a mixed number raised to the power of 1 whole number 2 over 3. Both numbers, that is the number itself is a mixed number, the power is also a mixed number. So we have 3 whole number 3 over 8 raised to the power 1 whole number 2 over 3. We have to evaluate that using the laws of indices, that we have discussed in this particular session. Alright, so we have 3 whole number 3 over 8, 3 whole number 3 over 8 raised to the power 1 whole number 2 over 3. Anytime you have mixed numbers in mathematics, a mixed number is a number that has a whole number and also a fraction. Alright, that's called a mixed number. Now we always convert it to an improper fraction. Take the denominator of the fraction, multiply to the whole number and add the numerator together. So 3 whole number 3 over 8, we are going to multiply 8 by 3, that gives us 24, and we add it to 3, that gives us 27. So 3 whole number 3 over 8 means 27 divided by 8 raised to the power of 1 whole number 2 over 3. We also change that to an improper fraction where we use 3 to multiply 1, and of course we add it to 2. So 3 times 1 is what? Is 3 plus 2 is 5. So this guy is giving us 5. It's giving us 5 divided by 3. Alright, so this just lands us directly in the last law of indices, where a number is raised to a fractional power. You take the denominator of that fraction as the root sign. Okay, so here is 5 over 3. Denominator is 3, so we have cube roots. So we're having cube roots of 27 divided by 8 all raised to the power 5, which is equal to cube root of 27 is 3. That's multiplying 3 times will give you that. So we have 3. We have 3 divided by cube root of 8 is 2. All raised to the power what? 5. Alright, so this equals to 3 raised to the power 5 means we multiply 3 5 times, and 2 raised to the power 5. That 5 there as the power will affect both numerator and denominator. So we multiply 3 5 times, and we also multiply 2 5 times. So 3 5 times is 3 times 3 times 3 times 3 times 3. Divided by 2 5 times is 2 times 2 times 2 times 2 times 2. So this is equals to 3 times 3 is 9. 3 times 3 is another 9. That is 81. 9 times 9 now times another 3 is 243. So when you multiply 3 5 times, you have 243. So this gives us 243 divided by, when you multiply 2 5 times, 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So when you multiply 2 5 times, you have 32. So we have 243 divided by 32. This becomes the solution to that particular example. I'm sure we're on the same page. Now that we have done sufficient examples, I am sure that you understand how we can use these laws of indices to be able to, evaluate mathematical problems. And finally, we have the last question, 16 over 25 raised to the power 1.5. Now, this question is peculiar in a way that our power is actually expressed as a decimal point. So we have 16 over 25 raised to the power 1.5. All right, let's quickly look at that solution and see how we can go about that using the laws of indices that we have discussed so far in this session. All right, so we have 16 over 25 raised to the power 1.5. I have noted earlier, anytime you see a decimal number in mathematics, try as much as you can to always express it as a fraction if it is necessary, if you need to. All right, so we have 16. We're having 16 over 25 raised to the power 1.5. Okay, so this means 16 over 25 raised to the power 1.5. One decimal place, that's 1.5. 0.5, one decimal place, so that's divided by 10. Two decimal places is always divided by 100. Three decimal places is always divided by 1000. Don't you ever forget that. All right, so 1.5 means one decimal place, so that means 15 divided by 10. So we have 15 divided by 10. All right, so this is equals to 16 all over 25 raised to the power 15 divided by 10. We can break it down because at this point it will not be ideal for us to find 10 roots of 16 divided by also 10 root of 25. Thinking of a number that when you multiply 10 times you have 16, and when you multiply, in mathematics we always try as much as we can to simplify things, to make it simple. That's the aim of math. But the issue some students have is that instead of simplifying, they end up amplifying, which is why most students don't really enjoy mathematics as a subject. Math is simple, math is interesting if you can play by the rules. Alright, so here we're having 15 divided by 10 as the fraction, which is the power of 16 over 25. Now, it is not ideal for you to begin to think of taking 10 roots of 16 over 25, because you'll be thinking of a number that when you multiply 10 times you have 16, and when you multiply 10 times you have 25. Believe me, that number is crazy. Alright, so what you observe here is that both 10 and 15 are multiples of 5. They are multiples of 5, meaning we can use 5 to cancel them to reduce these values. Okay, so 5 into 15 will give us 3, and 5 into 10 will give us 2. So this is actually 3 over 2. You see, it's simpler now. It's easier for you to work with 3 divided by 2, which is the same value as 15 over 10. So here we'll be taking square root of 16 over 25 all cubed, instead of using 10 roots of 16 over 25 raised to the power 15. That is too outrageous. Alright, so we have reduced 15 over 10 as 3 over 2, so it's easier to work with this. Alright, so this now becomes this is now square root. Denominator of the fraction is 2, so that gives us square root. So we have square root of 16 divided by 25, all raised to the power of what? 3. Now, of course, 16 is a perfect square. I've explained that earlier. 4 times 4 is 16, so 16 is called a perfect square. So square root of 16 will give us 4. So we have 4 divided by square root of 25. 25 is equally a perfect square. 25 is 5 times 5. Okay, so square root of 25 will give us 5, all raised to the power what? 3, which means 4 cubed. The power affects both numerator and also denominator. 4 cubed divided by 5 cubed. 4 cubed means we multiply 4 3 times, 4 times 4 times 4. That will give us 64. Divided by 5 cubed means we multiply 5 3 times. 5 times 5 is 25 times another 5 is 125. So we have 64 divided by 125. Ladies and gentlemen, there has been an interesting session on the topic indices. Take note, we have said today that indices are powers, indices are exponents. When you write a number raised to a particular power, now that power is called an index when it's 1, and when it's more than 1, we call it indices. Alright, so what we have discussed so far in this session is to get an understanding of the laws of indices, which I had explained. And you recall that a raised to the power m times a raised to the power n is a raised to the power m plus n. When you multiply, you add the powers. And also a raised to the power m divided by a raised to the power n is a raised to the power m minus n. When you divide, you subtract the powers. Alright, the third law was that a raised to the power 0 is 1. The fourth law was a raised power m times a raised power n is a raised power m times n, which is a raised power mn. Okay, so you multiply those two powers in that way. And also the other law was a raised power negative m is 1 over a raised power m. Anytime you have a negative index, that become inverse of that. And also a raised power m over n is actually a raised power that's a raised power m over n is n roots of a or raised power m. Whenever a number is raised to a fractional power, the denominator of that fraction picks a root sign, and the numerator still remains the power of that number. And we have in the the last few minutes see how we can use these laws to evaluate problems that involve numbers with powers. And I'm sure that you have a good understanding of the topic. Now on our next session, still talking about indices, we'll be discussing exponential functions, where we'll see how numbers that have powers can be used to form an equation. Such equations are called exponential functions. We'll see in the next session. Thank you.